Well, hello. I'm hopefully unmuted. Someone will surely tell me in the chat if I'm not. We are going to be doing some nth term of sequences today. This is aimed for KS3, so it's aimed at years 7 to 9. If you are year 6 and 5, you may still cope with this. It's okay to be here if you're younger, and also if you're doing GCSE, but if you wanted some revision, this is also very valuable because this is going to be all stuff that's on your GCSE. So everyone who is here is welcome. If you're here live, brilliant. Take part and say hello to me in the chat, and I'll try and say a little hello when people are doing the starter in a second. If you're watching this back in 10 weeks, in 10 months, in 10 years, then this is all hopefully still going to be useful and relevant. Just ignore the bits where I say about today being gloomy with a possible snow, because obviously it's not, and you're not in lockdown anymore. We hope. Okay, let's get straight into the video. Right, so we've got to go straight on with it. I'm aware, I forget that I've got a 9-second thing, so I just got to sit there and forget that I'm live now and I need to get started talking. Silly man. Right, so we're going to go straight to the PowerPoint, and here we've got a question for you to be thinking about while I say some hello. So I'm going to say hello to Eddie, hello to N, hello to Maria, hello to Shana, who's just joined me from my maths lesson. You were with me a little while ago, but we're going to do a bit more work on the nth term of sequences, so hopefully this will be useful in helping you with that as well. We talked about this earlier in the week, so it's all a bit fresh in your mind, which is good. See if anyone can spot what of all these numbers got in common. There might be more than one answer. Feel free to use the live chat if you're with me live, or if you're not with me live and you think of an answer we don't talk about, put it in the description below, or pause the video and put it in the description below now. Feel free to use the description below the line to tell me some answers as well, and I'll obviously happily feedback. So I have seen, Eddie, you're absolutely right. I've got some people sent me different things about lessons they've done. It's lovely seeing people's work. It really has been interesting to see all that. I've got some symmetry stuff from other people as well. So anyone got any ideas? This is a tough one. I've put this one just to trick people. And the answer is, I haven't got a drum kit, but every number in this in this list, if you are colouring in the holes, has one hole to colour in. That's a horrible reason. Is there something? That's my answer anyway. You might have other answers that are also true. Good afternoon, Logan Schofield. Okay, every one of these questions, there is one hole to colour in if you were colouring in the holes in the numbers. Okay, so 6, 10, 207, 921 and 135, 302 all have one circle or one hole in them. Okay, so let's move on. What we're talking about today. Don't remember, I've still got that algebra substitution. I keep forgetting to get rid of it, don't I? We're not doing algebra substitution. We're doing nth term of sequences today. Here's some work that I got sent to by Austin when we were doing ratios. Feel free to show me photos on the Facebook group with your parents or yourselves, going onto the Facebook group and adding yourself to Mr. Harris School of Maths Facebook group, or send me an email directly if you want to show me your work. And Shiana was asking me how to contact me. There's another way of contacting me there. There's an email address for me. You can contact me with any questions you've got, any topics you want me to go through, or just to show me photos of your work, because I loved seeing the work that people have done. So, moving on. Hopefully, I might even not even be in the centre of the screen here, because I think I am. I think I'm in the right place. Hopefully I am. I'm going to move myself over because I can. So, we are going to be talking about the nth term of sequences. Now, sequences have things that generate them. In a second, I'm going to show you what I'm talking about. Sequences are just lists of numbers, and the ones we're going to be talking about are linear sequences, which means the gap is the same each time. So as we go on, the gap is the same. Let me disappear for a second, and we'll move forwards, and we'll see. Here is a sequence. 4, 11, 18, 25, 32. Now, it is basically a times table that's disguised. Now, if we looked at the gaps between all these numbers, the gap between 4 and 11 is 7. The gap between 11 and 18 is 7. The gap between 18 and 25 is 7. The gap between 25 and 32 is 7. Therefore, that must be very similar. It must be like a cousin of the 7 times table. They must be related. And actually, we can look at these things and go, well, how can we say we're related? Well, we don't call the 7 times table the 7 times table in algebra. We call it 7n. To make it more easy to write, because having to write 7 times table every time would be too complicated. But if you look at 4, 11, 18, 25, 32, I'm not sure that we can't see that if you take 3 away from 7, you get 4. If you take 3 away from 14, you get 11. In fact, if you take 3 away from every single one of the 7 times table, you get the new one. Therefore, we call it 7n minus 3. Now, I know what you're thinking. That looks a bit complicated, Mr. Harris. Can you explain a bit further what you're talking about? Well, of course I will. I'm going to go and do some more practice of these, and hopefully, from seeing it on my whiteboard, we'll be able to do them. So let's go live into my studio, and hopefully it's working. And here we go. So let's look at a new question. We've got this question. If I get my pen working, 3 and 8, 13, 18, 23. It's basically a disguised times table. So we don't know what the formula is for it. And this could be called a general formula. It could be called an nth term. It could be called the term generator. They all mean the same things. So what we're going to do is we're going to say what I think the gaps here are 5, 5, 5, 5. So I think to myself, well, what do I know that has a gap of 5? It's the 5 times table. 5, 10, 15, 20, 25. They have a gap of 5 also. And we call them 5n. But now, imagine I'm trying to go back. How am I going to get from 5 to 3, 10 to 8, 15 to 3, 20 to 18, and 25 to 23? And I think there'll be people in the chat. I'll move the chat now. I've got different screens, lots of people writing. I think we're going to have people saying it's 5n minus 2. Because it's take away 2 each time. Okay? So each time we go through the 5 times table, if we took away 2 from every term, we'd get that. So you can think of it as the 5 times table take away 2 if you want to. But we write it as 5n minus 2. Notice how it's not scary. Now, we can even work backwards. Sometimes we'll be given 6n plus 4. So we're given the general formula, or the nth term, or the term generator. What we then do is we go, well, we need n to be 1, n to be 2, n to be 3, n to be 4, and n to be 5. So we take this number and swap it. 6 lots of 1 plus 4 is 10. 6 ones of 6, add 4 is 10. 6 lots of 2 plus 4. 6 lots of 2 is 12, plus 4 is 16. And we know it's going to go up. It's going to be like the 6 times table. So we can just count in 6s now. 22, 28, and 34. But we might even be asked, what's term 50? Someone might just say, oh, okay, well, we don't have to count all the way up to get to term 50. We just go, okay, n is 50. We're going to do 6 times 50 plus 4. That's why these sequence generators are so good. Because once we know what term number we want, we can put the number in, and it's 304. What question would you like to ask, Maria? Just feel free to do so. And if you ask a question, you just type it in the chat, and I'll try and answer it as soon as I can. Okay? If we wanted to know what the 100th term was, we would put n equals 100. 6 times 100 plus 4. Always plus 4. There's no n with the 4. So we're not allowed to add 6n to 4 because 6n plus 4, this is just a number. This has got letters with it. And you're not allowed to add numbers to letters. I see some people writing this and I go, no, sad face. You're not allowed to do that. What you have to do is keep it as 6n plus 4. And we'll rub this out. And if we're doing the one, we'll just finish the one we were doing, 604. I'm sure some people have worked that out. Let's do another couple before I set you the task of going through the worksheet that is below us. So, we've got a new question, 7, 10, 13, 16, and 19. First thing is find the gap. Find the gap. Then we write down that times table. This is the 3 times table, 3n, 3, 6, 9, 12, 15. Some of you may even start doing this in your heads. Okay, then we want to go, how do I get from here? Logan, how are we getting from 3 up to 7? Okay, how are we going through those? And he's absolutely right, it's 3n plus 4. He's right what you said on the chat here, because it's 3n plus 4. So we're going to keep going up like that and keep adding things, adding 4 each time to get our times table up to the sequence we wanted. Here's another type of question where we've got a term generator. We've got 8n minus 3. What we're going to do is we're going to, well, what about when n is 1? We're going to go, if n is 1, we need 8 times 1 plus 3 is 11. 8 times 2 plus 3 is 19. And we notice it goes up in 8s because it's the 8 times table. This bit tells us it's like the 8 times table. So we can just count in 8s from now on. 8, 8, 8. So I'm doing like a little shortcut. I can just count up in 8s each time. And then we write the sequence out properly. 11, 19, 27, 35, 43. And that is the sequence that goes with that term generator. So I've got 2 questions here. One going from the sequence back to the sequence generator, and one going from the nth term to the sequence. You might even sometimes, and this is the scary bit, you might even sometimes have to do some which go downwards. It's not too scary. But if we've got one that goes 8, 6, 4, 2, 0, minus 2, it'll even go behind the line, below 0. When you do the gaps, you write minus numbers, not plus numbers. So these are going down 2, so we write minus 2. Now the minus 2 times table, all of you will know, but you'll just think of it as the 2 times table, but with minuses in front of them. Minus 2, minus 4, minus 6, minus 8. It's no different. The only thing to be careful is to get from minus 2 up to 8, imagine a temperature scale. We're at minus 2, there's 0, and there's 8. To get up that far, it has to go up 10. So this will be plus 10, and I will write minus 2n plus 10. But as my year 9s discovered the other day, actually, we can write that down as 10 minus 2n instead of minus 2n. They're both the same answer, so they're both the correct answer for this question. Minus 2n plus 10. Remember what I was saying in the chat. You're not allowed to add the 2n to the 10 and get 8. It must be 10 rather than 8n. So that you can't get 8n here because we're going to try and get from our sequence, from our times table, this is the times table, up to the sequence that I gave you. This is the question. Make that a bit smaller. So, if we're trying to do that, we can do one more. N. Sometimes we add, sometimes we subtract. Thank you for explaining that. The reason it's not 8n minus 2 is because the n bit is always the gap. And the gap here is minus 2, minus 2, minus 2. We're not doing any guesswork here. Everything is a step-by-step process. The amount of n is always the difference. And these are all minus 2. That's where we've got our minus 2n from. The plus 10 is because to get from the minus 2 times table up to 8 is 10 more, which is why it's minus 2n plus 10. Thank you for those people taking part in the chat. it is all useful to see how your thoughts are developing. So let's go back to my studio for a second. I don't know if I'm still going to be on the screen. Let's go back and see. So, we have learnt today, if I give you a sequence generator to find the first 5 terms, or even the 10th or the 50th or 100th term by putting 10, 50 or 100 in and swapping it with n. If I give you a number sequence and say to you, this is a linear sequence, that means the gap is the same each time, by finding the gaps, you can find what the times table is, and we can then work it out. Now, in the link in the description below, you'll see a worksheet with some questions to practice this. Why not download that worksheet and have a go at the questions now to see how well you understand it? See if you can get them all. Okay? And I will adapt it. I can't remember whether I put answers in it or not. I will put some answers here, or if you're trying to check your answers, feel free to put questions in the description below this video and say, oh, have I got this one right? Okay, so today, why don't you go and complete the nth term sequences now while it's fresh in your mind? Maybe go and complete the Corbett Maths 5 a day, which is good every day to improve you. And there will be one every day of the year, so you can find one for today, find the level that suits you, and have a go at it. It might well be that the foundation one is a good one for you in years 7, 8, and 9. Have a go at it, and if you've got any questions from that, email me, come back and put a question in a description to a video I've done. You can send me pictures to Facebook or to schoolofmrharris@gmail.com. And remember, this week's Taskmaster, if you're doing it live, I am still waiting for a few posters. Any posters I get by the end of the week will qualify for this week's Taskmaster Challenge, and I'll be scoring points for people for the challenges they've done so far this year. So, at the moment, I've got a couple of entries. There's people who scored points. If you want to be on the leaderboard, you have to enter the Taskmaster Challenge. Okay, I've been Mr. Harris. Thank you so much for joining me. Look after yourself, and I will be live again for this year group on Monday, where we'll be doing something else, and I'll release the timetable on Facebook and onto YouTube over the weekend. Look after yourself. I've been Mr. Harris. You haven't. Take care.